Thanks, Flopine, for that really cool performance. This is maybe a first for real-time live, having shaders coded and performed live to music. Flopine is a demo scene and PhD student at the Paris 8 University within the NREV research team. Thank you so much. That was really great. I'd like to welcome everyone to the 2021 SIGGRAPH Real-Time Live show. My name is Christopher Evans. I'm the Real-Time Live chair this year, and I'll be your host for tonight. For over 20 years, I've been volunteering for ACM SIGGRAPH, and in that time, I've worked the doors of the show as a student volunteer. I've helped produce the show, working on the subcommittee. I've even been on stage multiple times with my friends and colleagues, and a few of those times we were lucky enough to bring home the award that night. I think this might have been what was on Paul Jeremiah's mind when he asked me to host the event tonight. He knew that I had that video game completionist part of my brain, and I just wouldn't be able to say no. So here we are. So what is Real-Time Live? For anyone new to the show, tonight we're going to see some of the year's greatest interactive demos rendered in real time. Nothing you see here has been pre-recorded. Our show tonight spans the planet from Beijing to Europe. You're watching the nail-biting suspense of fresh pixels. We're working hard to bring you fresh pixels, people. That's rare. These pixels and more were evaluated by this year's distinguished jury. Tonight, you're going to see the projects that made their cut, and later they will decide which team is crowned best of show. It's been awesome to work with so many respected industry veterans. I'd like to thank Peter Sumanaseni, Senior Technical Artist at Epic Games, Andrew Maximoff, Founder and CEO at Promethean AI, Nicholas Schultz, Principal Graphics Engineer at Cloud Imperium Games, Nina Stracciolini, Lead Technical Artist at Insomniac Games, Ryan Trowbridge, Principal Software Engineer at 343 Industries, and Aaron Conover, Technical Artist at Unity Technologies. Lastly, I'd like to thank our amazing subcommittee, without whom none of this would have been possible. And people say that all the time, but quite literally, I'm on paternity leave right now, father of 2 newborn twins and a crazy toddler. So yes, believe me when I say that none of this would have been possible without amazing people like Luke Tannenbaum. Luke's sitting right here. It's his birthday today. Happy birthday, bud. Saskia Hunewegen. Saskia lined up the pre-show. She's worked tirelessly to make the event really awesome. Yibing Jiang. Yibing is the SIGGRAPH 2022 Real-Time Live show chair, and she's going to be doing this next year. And Carlos Gonzalez Ochoa. Carlos is this year's games chair. Not pictured here, I'd really like to give a shout out to Jenna Feldman. Jenna works in conference management, and she is really the glue that holds Real-Time Live together. She works very hard to make sure that this show is a success every year. So this year, like last year, we're going to have an Audience Choice Award. You're going to get to vote. If you look here, when you log into the platform, you're going to be able to vote through this widget. We're going to tell you later how you can vote. And when we say voting is open, we're going to start a 5-minute retrospective that shows a lot of cool content from previous Real-Time Live years. And that's when you and the jury are going to be casting your votes. So the jury is going to go ahead and crown the best of show, and you all will crown the Audience Choice Award. So with that, let's go ahead and get started and jump into it. First up, we have Levici Music Series, real-time immersive musical circus performance. Levici is broadcasting live from the mocap stage at Animatrix Film Design. They are presenting a real-time digital circus, combining complex, death-defying motion of live acrobats with real-time performance capture and rendering. Presenting is A. Thomas Goldberg, Creative Director of ShoCap Entertainment, a 26-year veteran of computer graphics and animation, and Samuel Tetro, trained circus artist, former Cirque du Soleil, co-founder and art director of the Seven Fingers Montreal-based Circus Collective.
Hello, everyone. I'm A. Thomas Goldberg of ShoCap Entertainment. And I'm Samuel Tetro of the Seven Fingers. We'd like to introduce you to Project Levici for live and virtual circus, our collaboration to merge circus arts with the languages of film, animation, and video games using virtual production tools and real-time motion capture. And now, please enjoy this live presentation of We Won't Forget, performed to the words and music of Shane Koichan.
Remember how we forgot? Remember how no one ever really died in the wars we fought? Because each gunshot came from our fingertips, and we never really kept them loaded just in case. Because each enemy was a friend, and none of it was about oil, religion, or land. It was all just pretend. Remember how we used to bend reality, like we were circus strongmen, like our imaginations were in shape then, like we were all ninjas trained in the deadly art of did not. Like I totally got you. Did not. Remember how we forgot? Remember how our parents told us never to look directly into the sun, and how we were their son, so we never looked directly into the mirror in fear that we would go blind? Remember how we used to find any old reason just to call someone we were crushing on? Like we could just pawn off our sense of embarrassment, buy a chunk of courage that would last just long enough to have us asking them about math and stuff. And how stuff was just stuff. Like I heard you getting braces. Now braces somehow were and still are kind of hot. Remember how we forgot? Remember how we all caught mono? And our folks would go, oh, the kissing disease. And our first steps into gangsterhood had us saying, mother please. Even though we'd never really kissed anyone, even though we never did half the things we said we'd done. We just spun yarns like Rumpelstiltskin spun gold. We told ghost stories, never realizing we would one day ourselves become ghosts, haunting the hallways of schools, breaking all the rules of silence in the library. But we had no chains to rattle, no voice to battle the fact that we had no vocal cords. We had only fingernails on chalkboards. And they would scream, shout, and yell, trying to tell ourselves what experience can teach is what no teacher taught. Remember how we forgot? Once upon a time, we were young. Our dreams hung like apples, waiting to be picked and peeled, and hope was something needing to be reeled in so we could fill the always empty big fish bin of the one that got away, and proudly say that this time, impossible is not an option. Because success is so akin to effort and opportunity, they could be related. So we took chances. We figure skated on thin ice. Believed that each slice of life was served with something sweet on the side, and failure was never nearly as important as the fact that we tried. That in the war against frailty and limitation, we supplied the determination it takes to make ideas and goals the parents of possibility. And we believe ourselves to be members of this family, not just one branch on one tree, but a forest whose roots make up a dynasty. So when I call you sis or bro, it's not lightly. When I ask you to remember, it's because the future isn't what it used to be. So remember now. Pay tribute to every sacrifice laid upon the altar of somehow, for all the times somehow we overcame, somehow we pushed on, somehow we've gone the distance, and in going there we possess the freedom to map the uncharted lands of any and everywhere. We are unbound, 6 feet above the underground where we will all one day rest. So until then, test the limits, test the boundaries and borders, as if the headquarters of potential lay just beyond the world's edge. Let the belief that hope belongs to us all be the pledge you take to make the unachievable as inconceivable as the false fact that we were never here. We were here, and our memories are as dear to us as every slow motion moment to held breath. So remember every instant before death, every first kiss, first dance, near miss, last chance, yes, no, maybe so. Let us go the distance once more. Let us remember all the moments that were and were not. Like the point is something we can get, and what we can get is what we got. Because all we have are the times between the moments we connect each dot. So live and remember. Burn like an ember, capable of starting fires. Like each moment inspires the next. Like memories of the context we put ourselves in, so that life becomes the next of kin we need to notify in case of a big bang or extinction level event. Let now be our advent. Let us live like we meant it. Let us burn like we mean it. Because this world doesn't give a shit if we end in a train wreck or a car crash. If our story ends with a dot or a dash, if we were dust or ash. Because all we were is all we'll be, and all we are is the in-between of so far, so good. So forget every would, could, or should not. Forget remembering how we forgot. Live like a plot twist exists now and in memory, because testament that somehow we bent minds around the concept that we see others within ourselves, that self-knowledge can't be found on bookshelves, so who we are has no bearing on how we appear. Look directly in every mirror, realize our reflection is the first sentence to a story, and our story starts. We were here.
Please give a warm virtual round of applause to our talented performers, Sidonie Adamson, Cameron Fraser, and Kasha Kanaka. If you'd like to learn more, please join our production session tomorrow at 4 p.m. Pacific time. Thank you, guys. Take a bow.
Wow, that was amazing. There's definitely another first for real-time live. That was really cool. Up next, we have I Am AI, AI-driven digital avatars made easy. You can see a deep learning-based system that allows anyone to synthesize animated digital avatars from audio or text input, generating real-time talking avatars from only one picture. They will showcase how this technology can enhance video conferencing and avatar creation. Presenting are Brian Catanzaro, Vice President of Applied Deep Learning Research at NVIDIA, Arun Malia, Senior Research Scientist, and Kevin Shi, Research Scientist at NVIDIA.
Making digital avatars is a notoriously difficult, tedious, and expensive process. It requires a team of digital artists and engineers with professional hardware and software to make a lifelike digital character. Wouldn't it be great if we had a tool that could make a digital avatar using just a single photo of a person? In this demo, we will show you a technology that does just that, as well as its application to video conferencing, storytelling, and beyond.
Hi, this is Kevin.
Yeah, ready for the interview?
Yeah.
So it says you're presenting a new AI-driven digital avatar technology to me today. Tell me all about it.
All right. Before we begin, can you tell me how I look on your screen?
Well, looks like you're wearing a blue shirt and I've recently shaven.
Would you believe me if I told you I'm actually wearing a t-shirt, hat, and mask and chilling in a coffee shop?
Wait, no, that's definitely not what I'm seeing on my end.
Yes. What you're seeing is the new AI-driven digital avatar technology I want to demonstrate to you today. The digital avatar you are speaking to is created by using just a single photo of me. I was never 3D scanned, nor were my photos used during training. The digital avatar creation is instantaneous, so I can quickly create a different avatar by using a different photo. In fact, let me quickly create an avatar. Here's one using a photo of me in a suit. And here's another one. It's using a photo taken last week.
Wait, how are you getting all those facial emotions out of a still photo?
Sure, let me explain. It all starts with speech. We transmit only my voice to your machine over the internet. The voice is then used to drive an AI model called audio to face, which is a technology that takes my speech as input and generates lip-synced facial motions and expressions for a 3D head model in real time. The system generates natural 3D facial motion, including emotions, lips, eyes, and head motion. The motion of the 3D head model is then fed to another AI model called vid2vid, which can animate a photo of a person. Since it takes audio as input, we can drive facial animation using any voice. For example, I can say, hey, this is my funny voice, or in any language, hello, mera naam Arun hai. By switching to a different photo, we have a different avatar. This is the power of having an AI model that can create a digital avatar by using just a single photo. We can even create cartoon avatars with this technology. This is what we get by simply plugging in a cartoon avatar image. By using StyleGAN, we can generate a wide range of 2D avatars. Using this technology, we can bring them to life, like what you're seeing right now.
Nice. Okay, so how do you get it to work with so many different avatars?
vid2vid achieves this amazing capability because it was trained with a large number of videos, which included various facial appearance features and motions. Now, let me change back to a photo of the real me.
Oh, okay, so it's still hard to believe how you can get this to work so smoothly in a video conferencing pipeline. Also, aren't deep networks really slow? And what about the bandwidth?
Our AI models are optimized for GPUs, allowing us to easily achieve 30 frames per second using a PC with an RTX GPU. It's also extremely bandwidth efficient because we never have to transfer a full image over the network. Since we are not even using a webcam, without this technology, all you'd be getting is just my voice.
Sweet. Well, that does sound perfect for my next business trip.
I'm glad you like it. Sorry, the coffee grinder in the background is making a lot of noise. Let me mute my mic and quickly switch to text.
Wait, text? Are you sure you don't want to just like call me back later when you're somewhere quieter?
Hi, Kevin. Hope you can hear me.
Yeah, loud and clear, but you said you were texting?
Yes, my microphone is on mute and I'm typing on my laptop. Let me introduce the third exciting technology, RAD-TTS. RAD-TTS is our latest text-to-speech method based on deep learning. It is robust and can synthesize the lifelike speech from arbitrary text inputs in milliseconds.
Wow, that's really convenient. So with everything you've shown me thus far, you could just be like calling in from a beach and nobody would know.
Absolutely. This digital avatar creation technology can bring video conferencing to the next level.
Yeah, I can see that. Are there any other applications of this work you'd like to show us?
It also allows for virtual assistants and accessible content creation. All you need is a single picture. RAD-TTS can even personalize the voice, meaning that we can even narrate a famous storyline with our own characters. For example, I'm going to create an avatar to represent a famous character from the novel, A Song of Ice and Fire, and make her speak her signature sentence in the book.
I am Daenerys Stormborn of the House Targaryen, the first of her name, the Unburnt, Queen of Meereen, Queen of the Andals and the Rhoynar and the First Men, Khaleesi of the Great Grass Sea, Breaker of Chains and Mother of Dragons.
Oh, that's really impressive. So how much control do you actually have over the speech output?
Not only does it do casual conversation, but it can sing too. Check this out. Please stand up. Please stand up. Please stand up. Because I'm Slim Shady, yes, I'm the real Shady. All you other Slim Shadys are just imitating, so won't the real Slim Shady please stand up?
Nice. Well, I definitely didn't expect that. Well, hey, thanks for interviewing with us today. We'd love to integrate everything you've shown us here. When can you start?
Awesome. As soon as I'm done with my coffee.
I hope we've convinced you that there's an easy way to create digital avatars for real people as well as cartoon characters. It can be used for video conferencing, virtual assistants, and many other applications. We can't wait to put this technology in your hands and see what you invent with it.
Thanks, guys. That was really, really cool. Up next, we have Shading Rig, dynamic art directable stylized shading for 3D characters. We'll see a new framework to allow artists to craft how light and shade fall on cartoon characters. Now games can support dynamic lighting while preserving an intended art style. Presenting is Lohit Pedikam, a researcher at CMIC, the Computation Media Innovation Center at Victoria University of Wellington. He's a recent PhD graduate who has worked at OLM Digital, Weta Digital, and 8i.
Thank you, Chris. Hi, everyone. My name is Lohit, and I'll be taking you through our project called Shading Rig. Shading Rig is a new framework in which artists can edit toon shading and control how it responds to lighting changes. This is really important because toon shading often produces these undesirable shadow shapes that need to be cleaned up and edited before production use. Vertex normal smoothing is used to smooth out these shadow shapes, but it often loses high-frequency details that could be important. So many games often opt to bake or explicitly model these lighting effects into the geometry. What you're seeing here is not your internet dropping out, but the limitation that it really just snaps to different lighting configurations. We can't really achieve smooth transitions with this. So that's why we developed Shading Rig. It allows us to precisely animate these really smooth shading transitions using our novel parametric shading edits. These shading edits or primitives, when used in a game engine, will dynamically correct the toon shading to better match the art-directed style of hand-drawn concept artwork and cartoon shading styles. Today, I'll be going through how we can build and animate one of these shading rigs, and then I'll deploy it in a game engine to see how it runs in a dynamic scene. First off, let's go through the basic editing framework. I've got set up a basic toon shader with vertex normal smoothing, and I can start editing by moving this primitive close to the surface. You can see how it's got this circular fall off, just like regular point lighting, but I can use these parameters to uniquely shape the boundary between light and shade. So here, anisotropy makes this shape longer, sharpness gives us this sharp endpoint, and I can take intensity gain, make it negative to indicate a shadow at this point. Also, let's fill out the rest of the details. Some of these are already shaped in the interest of time, but I can show a few other properties like bend, which curves the shape like so, bulge, which adds asymmetry or weight to either side, and I can use rotation to orient the shape as I need it. So these shapes are pretty simple, as you noticed, but we can use a unique property that lets us dial in some detail from the underlying surface like this. And it lets us bring some more nuance to the shapes that are not expressed by the simple parameters. Cool, so that's already looking way more art-directed, more readable and intentional because we've been able to directly manipulate the shadows, much like an artist would when drawing in 2D, without being limited by physical or mathematical rules. Now, this shading rig is static, so it's not going to uphold our artistic intentions for every light angle. Like, I don't want it to do this when the light is over here. But we developed shading rig to be fully animatable, so all we have to do is keyframe the appearance at different lighting angles. So I'm going to, when the light angle is back here, I'm going to keyframe this edit to recede a little bit. And just with 2 keyframes, we've achieved the most basic example of the shading rig, dynamically art-directing the toon shading result. Now, continuing like this, and with a few more edits, we can achieve a more complicated example such as this, where many different lighting effects have been animated precisely to appear, disappear, or settle at different lighting angles and in a very stylized way. Now, this animation has been done for all 360 degrees of a key light rotation, and that's so that when I hit export, this is exporting to a game engine, so that, and it allows the renderer to know exactly what to do in every lighting situation. So I've got my character here in Unreal Engine 4. Here, the face shadows are unedited, and I just have to do hit re-import to bring in our details we created in the animation. So as I flip through the previous modes, we can see just how much of a difference this has made to the intentional and art-directed look of our character. Now I've got this controller set up so we can take our character for a bit of a walk. And no matter what input I give, whatever state this character ends up being, I can know that her shadows remain on model because the engine is basically playing back the shadow animation we created based on the light direction in the environment and the current orientation of the character. So that's cool. But what if I want to make a change? Well, it's just a matter of going back into Maya, and I'll do a very simple edit just to show how fast we can iterate on these types of animations. So I'll take the no shadow, bring in some details like this. And so I've changed the no shadow, still simple, abstract, but in a different style. I've hit export to send it off to our game engine. And while we're still in the game, I'm just going to hit re-import, and we can see our changes update immediately. You can see the no shadow reflecting the changes that we created. Cool. So I'm really excited about this research because we've been able to, a couple of things, we've been able to precisely express our artistic intention in ways that artists already know how. That's through keyframe animation and point lighting design. And then our renderer was able to interpret and faithfully respect our artistic intentions without any artist interventions in a dynamic scene. Now, you can see this being used outside of games like an offline animation, where animators just want to freely animate a shot without worrying about huge post-production costs spent cleaning up every frame. Not to mention, virtual avatars can use this to keep their characters looking on model throughout a live performance or a live stream. Best of all, we didn't have to use any ad hoc methods or hacks, which can be counterintuitive and inflexible. Be sure to check out all the technical details in our upcoming journal paper, and I'll also be giving a technical talk later this year at SIGGRAPH Asia. So until then, that's been it from me. Thank you very much for listening.
Wow, that's such a pragmatic and artist-friendly way to improve cell shading. That's really cool. Up next, we have Quartet, virtual reality musical instruments for the 21st century. A VR musical instrument that explores the translation of performance, gesture, and mechanic from traditional bowed string instruments into a virtual implementation. Built with Unreal Engine and pure data, Quartet offers musicians a flexible and articulate musical instrument to play within a networked performance environment. Presenting is Rob Hamilton, Associate Professor of Music and Media at Rensselaer Polytechnic Institute in Troy, New York, and Chris Fisher-Lockhead, composer and violist.
Musical instrument design requires a careful balance of engineering and artistry. Quartet is a virtual reality musical instrument and networked environment that uses traditional and familiar physical gestures to drive musical performance. Using commodity VR hardware, like this Oculus Rift headset and controllers, Quartet models the physical affordances of bowed and plucked strings, creating abstractions of traditional instruments with the goal of leveraging musicians' tacit and learned knowledge for virtuosic performance. Audio for Quartet is procedurally generated, using physical models of strings from the STK Synthesis Toolkit and filtered through a simple simulated instrument body model. Using open sound control, data from the Unreal Engine is passed to a custom audio implementation built in the Pure Data programming environment. Quartet clients connected to a network server share a virtual performance space, with each performer's head, hands, bow, and instrument visible to other connected clients. This allows common ensemble gestural communication, such as head and hand gestures, particularly important for synchronization and communicating dynamic changes. Each instrument is built from the same set of rescaled and repositioned components, featuring 4 strings, 4 finger placement markers, and a single bowing bar. Current presets include the cello, the violin, the viola, the double bass, and an experimental instrument known as the orb. The single bowing bar on the instrument serves as point of contact for the virtual bow, with the positions of collision on both bar and bow, and the speed of the bowing gesture used to calculate bow pressure, while note amplitudes are locally driven by the speed of the bowing gesture. Node frequencies are calculated by tracking the position of the currently depressed finger marker along the instrument neck. Finger markers are set by pressing the left-hand X and Y buttons or the two controller triggers, with each button representing finger placement along one string. Pluck notes can be sounded at varying intensities, using continuous data from the right-hand controller trigger. Using the secondary trigger, chords of pluck notes at any placement of all four finger position markers can be played, with the speed of right-hand motion controlling the amount of note arpeggiation. Quartet can also ingest and display notated musical scores encoded as MIDI data. Light blue finger placement markers are displayed on the instrument neck, presenting the next four notes of the current piece being performed.
That was great, guys. Thank you so much. Next up, we're going to see the technical art behind the animated short Windup. A live look at the applied technical art behind the short created by Unity Technologies. We'll see procedural environment creation, animated foliage, and other material transition effects. Presenting is Chris Kong, Senior Technical Artist at Unity Technologies. Chris has 12 years of experience as an artist and technical artist focusing on modeling, shading, and pipeline.
Okay, hello, everyone. My name is Chris Kong. Very excited to be here. Windup is an Academy Awards qualified short made by Unity. It's been our dream to achieve an animated feature film quality fully in real time. Today, I'm going to show you 3 scenes in our movie to demonstrate how we use real-time technology to improve and speed up the animation production. And I hope the connection is fast enough so you won't get any lagging issues. Let's start. The first scene is called Playground. This part of the UI is called Timeline, and we could easily control everything, like the animations, lights, shadows, and post-processing on the fly. It's very convenient. And you can see the movie could play smoothly in Unity Editor. Here, I'm focusing on the foliage animation I made for this film. As you can see it here, in the corner place, or in the very beginning shot here. The animation on this branch is fully derived by vertex shader, which is a common method in game production. But the difference is, if we want to achieve a film quality, we need not only to use much higher poly count assets like this branch, but also we need to achieve a subtle and realistic animation to make sure all the branches and leaves look like be animated by hand by our animators. You may want to ask why you do that, why just animated them by hand? And the answer is once we got a nice quantity like this, we could simply scale the vertex shader to all the other trees and the bushes in the film, like what you can see in the look depth scenes. Look who is here. Let's welcome our little girl Kiki to join us. I will go on. All the trees and the bush here you can see is full quantity, no cluster plane at all. And you can see the vertex shader works perfectly on every single of them. The wind strength and the direction could be controlled by global parameter, and add some keyframes on the timeline so I can just show that to you guys. And the wind could be a quite strong one like this, or it could also be just like a breeze like this. And the direction, if you want to tweak it, it could be something really funny. We also could have a close-up shot to the animation. You found this animation still has enough details and variations. Looks pretty nice. Okay, the second scene is called The Wall. Roots and gate here have special meanings in the story, and the roots is also the thing I want to introduce to you. We generate all the roots in the film procedurally by using Houdini engine and Unity. Like what you can see here, I could easily create a root from scratch by clicking on the wall or any other collider you want to use. The roots will be generated following the curve naturally. Also, I could modify everything in real time until I'm satisfied with the result. It's very predictable. Same as all the other parameters like the attenuation and the radius of the root. Oh, that's probably too much. And the twisting. You could easily twist the root. Also, the UV set. Everything is adjustable. Since it's extremely easy to use, everybody in the team could modify the route if they need. Like, for example, our animator could easily move a route around if one of them just blocked the character on the camera. The last thing I want to show you is called the hospital. It's actually a turning point of the story, and you can see a lot of things happen here. And the effect I want to show you here is what in the very beginning shot is the frozen window. We can back to the look depth scene to have a better look, like here with our Kiki together. This is a fun shader effect, fully made by Unity Shader Graph. It includes a whole process of getting frozen. Like what you can see here, everything starts with a fogging up effect. I leave some clean area to show the father's face. And then the frost expands with the temperature dropping. In the end, the frost gets thicker and generates fractal patterns. And the thin fog around the patterns evaporates and disappears, which is pretty cool. All these three steps is controlled by a single parameter. Same as all the other effects I made for this film, it could be easily added and controlled by our animators in the timeline system. Okay, I think I almost done. One last thing is our latest face mocap application called Unity Face Capture is now available on Apple App Store. I highly recommend it you guys to download and try it out, like what I'm doing here. And thanks to the team Windup and the director Yibing Zhang, and special thanks to Mark and Brad from the Unity Live production team and all the people from SIGGRAPH. Thank you.
Great stuff. It's really good to see. Next up, we have the future classroom. Nearly 40 years ago, Ken Perlin introduced volumetric procedural textures into computer graphics. Now the time is finally right to be able to teach these topics properly within a new kind of classroom. You are about to witness a world premiere of the classroom of the future, a completely immersive experience for both students and teachers geared towards teaching computer graphics. Ken is a computer science professor at NYU. He is the founding director of the Future Reality Lab. He is a member of the ACM SIGGRAPH Academy. He's received an Academy Award for technical achievement, the VES 2020 Empire Award, and the ACM SIGGRAPH Computer Graphics Achievement Award. Ken also worked on Tron.
Hi, I'm Ken Perlin, professor of computer science at New York University and founding director of the NYU Future Reality Lab. Our lab's mission is to immerse people together into alternate worlds. Back when I was working in industry, working on the original Tron movie, I was unhappy about the fact that there wasn't any really good way of doing very naturalistic using textures. So I developed two related techniques. One was a procedural noise function, a volumetric function that acts as a kind of primitive for controlled randomness, and the concept of running a complete computer program at every single pixel of a surface, what are now called procedural shaders. And I started to create a lot of examples of this to give people the idea that this could be something powerful and they could incorporate in their own work. So other people started using it to tell stories about toys, about dinosaurs, about various creatures, even about characters that are also trees. Meanwhile, I pivoted from industry to academia, but as a professor, I hadn't been able to teach it the way I wanted to until now. The traditional classroom isn't really good for teaching computer graphics because people can't really work hands-on. And frankly, Zoom recently hasn't been any better. People are just left staring at each other. But thanks to Moore's law, now is a good time to explore the future of the classroom because reality is soon going to start looking like this, which means that classrooms can start looking more like this. So once we have the ability to reach in and interact through magical mixed reality worlds, we can have a better student experience, more enriching, more engaging, and most important, more collaborative. So here's a sneak peek, a world premiere of original software that I've written to teach my class in the coming year. I call it Clay because everything is volumetric. This is kind of what it looks like. Students are able to beam in using RGB depth cameras. They can choose to go in looking at a screen, or they can choose to wear a VR headset and see an immersive view, but always of the same world, and they can see each other. Because we're on Zoom, I'll show you the screen-based version. So if instead of doing a chemistry lesson, let's say we were interested in teaching computer graphics, much like I would like to teach in my coming class. So when I start to teach this, I usually start with something engaging, like making an animated character, because students are always really interested in animated characters. So let's, now it's a smart modeling system. So as I start building things, the pieces understand what they are and they know how they're going together. Notice the character starting to blink. And as I start building the shapes of the character understands that it's a biped. It starts auto-rigging. And so therefore it knows how to walk. I'm not really happy with the feet here. So maybe I'm going to make a little change to the feet. Maybe bring them up a little and pull them out. Oh, that's much better. But meanwhile, because everything is volumetric, I can also start changing the density of the underlying model. Let's go with our old friend, the noise function, and just apply this at every point in the volume. And because it's procedural, we can vary this density over time. Now, in the actual classroom, I would ask my students to create their own combinations of noise function to create different kinds of materials. So one student, for example, might decide to create a rock-like texture. And but the character still has animation, it's just made out of rock. Another character might decide to try to create some sort of foliage. But here you can see they've kind of created an incorrect foliage because they've started the low frequency at too low a frequency. So if we refine this a little, we get something that looks more like foliage. And in fact, we have a character that's also a tree. And in the shared classroom, this would be something that we could now take to a next level. We could have follow-on classes where students could learn how to add higher level behaviors to this character, so that maybe they could start interacting with people, walking up to people, and doing various types of higher level computer procedural animation. So what have we just learned here? We've covered many topics in just a few minutes. There's a natural continuity between lessons, and everything is tied together: modeling, animation, and procedural texturing. And it's a new kind of blended classroom where students can join our screen or in immersive VR. And it also has implications for workflow for commercial software as well. You can get involved with this because we share all of our code. Everything we do is open source, and we're going to have a fall workshop. You can either go to our website, or you can just drop us an email and create your own virtual worlds. Meanwhile, this week at this SIGGRAPH, we have a course that's all about our lab called Inventing the Future. So check that out, find out how you can be involved, how you can work with us, and we can collaborate together on creating the future. Because remember, the important thing is not what the future can do for you, but what you can do for the future. Thank you.
Wow, that was pretty great. Would have loved to learn computer graphics that way. I was definitely in front of the chalkboard. Next up, we have normalized avatar digitization for communication in VR, a highly robust GAN-based framework for digitizing a normalized 3D avatar of a person from a single unconstrained photo. We'll see a multi-user VR chatting system using Oculus Quest 2, where performances are driven by the headset and controllers. Faces are animated by speech-to-face synthesis. Presenting is Hao Li, CEO and co-founder of Pinscreen, as well as Distinguished Fellow at UC Berkeley. He has won the MIT TR35 Award in 2013 and the ONR Young Investigator Award in 2018. Lane Goldwhite, Senior Software Engineer at Pinscreen, previously won a BAFTA Award for Game Development. Zhujin Wang, Senior Researcher at Pinscreen, known for last year's deepfake, which he demoed on this show.
Hi, everybody. My name is Hao Li. I'm the CEO and co-founder of Pinscreen. And what we're going to show you today is a new system that we've developed here at Pinscreen that allows us to have multi-user telepresence using a VR headset. One of the things that is going to be new here is that we want to make avatar digitization accessible to anyone. So we're going to create avatars from a single input photo. One of our vision is that we can go beyond traditional 2D video conferencing and can have real immersive communication. So why don't we just get started, and I'm going to show you how it works.
Hey, yeah, so it's really simple. All I have to do is
I'm going to wear my VR headset. So I'm entering a virtual world, which we call Pinscape, and I'm taking my controllers. I can see my hands, and Zhujin is here. Hey, how are you doing?
Hello. Okay.
Cool. So we can see both of us. So both of our avatars have been reconstructed prior to this demo. But I want to show you how this entire avatar process digitization look like. So why don't you show it to us, Lane? We can actually see each of us in each of these different views. So I'm actually streaming right now in real time through the webcam interface, and Lane is going to explain explain to us how the avatar digitization works.
Yeah, sorry, I got a little ahead of myself. It's really simple. All you have to do is take a picture of yourself with a webcam. So I'll just look at the webcam. Boom, I took my picture, and now I just need to put my headset on and wait for the avatar to generate.
All right, so this is gonna take around 30, 40 seconds, and then there might be like 10, 15 seconds for download. So while we wait for Lane's avatar being generated, I'm going to explain a little bit how it works. So the technology is actually based on a state-of-the-art avatar digitization solution that we presented at CVPR this year. And it's based on a 3D version of StyleGAN that allows us from a photo to generate a 3D model of the avatar. Then in the second step, we use perceptual refinement and a combination of differentiable rendering to generate a parametric model that is fully rigged. And we also have a system that can allow us to generate the hair model of the person. So what's really cool is that we can generate the entire avatar and it's fully rigged. So, okay, there you go. Now we have Lane. So Lane is somewhere here in VR. Let me see where she is. Oh, there you go.
Hey.
Hi, Lane. So what you can notice right here is that even though the input photo was taken in a fully unconstrained setting, bad lighting condition, Lane was also wearing glasses, it digitizes a clean 3D avatar that can be rendered inside this virtual environment. Hey, Zijian, this place looks like Tron. Why don't we go somewhere a little bit warmer?
Yes, let's go to the desert maybe. Yeah.
Oh, wow. Okay, there you go. So we're here in the desert. Let's see where Lane is. Lane is here. Hey, Zijian.
Yeah.
Is there anyone you always wanted to be?
Yes, I took a picture of our SIGGRAPH real-time live chair, Chris, this morning. I want to turn to him right now. Yes.
Let's do it.
And you can see the input image there. Yeah.
Okay, so now it's taking a while. Oh, there you go. Wow. So that's a crazy input image from Chris that we took this morning. And it created a reasonably normalized avatar from his face. So you can fully control him. I like your t-shirt, by the way. And one thing that you can see is that we're really just using the Oculus Quest 2 to control our bodies. And Lane and Zijian, none of you are actually wearing mocap suits. Can you explain us how that works, Lane?
Yeah, of course. Yeah, we're just using the Oculus and the Oculus controllers for the Quest 2. And we have our own IK system for figuring out how the arm should move and the legs so I can walk around and move freely, interact, and look at the VR world.
Wow, let me get closer. So it seems like even your mouth is moving, right?
Yep. We also synthesize the lip animation from your speech.
Oh, wow. I can see my shadow on you. So is there anyone you always wanted to be, Lane?
Yeah, I want to try being Naomi Osaka. She's a tennis player, so I think I should pick an outfit that matches. I'm going to use an image that I found online earlier today.
Okay. Let's check it out.
There we go. How do I look?
Where are you? Oh, you're right behind me. Oh, you look exactly like her. That's pretty good. So that's just generated from a single input photo, right?
Mm-hmm.
I think we should all go to Japan now.
Yes. Shall we go to Japan? I think it's her hometown.
Yes.
Yeah, it looks like it could be Naomi's hometown.
Yeah. And shall we go to space? I think it's the trend now.
I think we're somewhere on the moon. Look at that there.
Yeah, maybe that's Earth.
That's really funny. So as you can see here, so this prototype system allows us to have real immersive interactions with each other as personalized avatars. And one of the cool things is we can be anywhere we want, we can be wherever we want. But to me, I think one of the most exciting things is that we can really enable social interactions, even though we're all in remote locations. So why don't we do a little emotes and show some dances? There you go. All right. So that was it. Thank you so much for watching. Stay tuned for more. We're going to build new products around Pinscape here at Pinscreen. And also, we're hiring. So please shoot us an email at jobs@pinscreen.com and see you around. Bye.
Bye.
Thanks a lot. That was really cool. I didn't think you'd use the crazy image of me. It's like, can I make a face like this? Okay, well, it's been really great to see so many amazing demos. I want to thank all of the teams for presenting their work live for all of us. You really can't understand how difficult it can be to pull this off and to sit in front of thousands of your peers and demo your work live. So now is the time, before the time that you've all been waiting for. You can go ahead into the platform and viewers can vote for your favorite. Our jury is going to convene and they're going to vote for the person, for the team that is going to be crowned the best of show. And we're going to kick off a 5-minute real-time live retrospective showing pieces from over the years. And we'll be back in 5 minutes to talk about who won. All righty. Welcome back, everybody. So we have the Audience Choice Award. You all have chosen the Levici Music Series, Real-Time Immersive Musical Circus Performance. That was really, really amazing, really awesome stuff. We are going to virtually call A. Thomas Goldberg and Samuel Tetreault up from the virtual green room. This will take a second. It was so cool to see all the acrobatics and everything. This, again, I can't stress how difficult that would be to pull off at the real show. Hey guys, congratulations.
Wow, this is it's amazing and unexpected.
We've been having just a ton of fun together working on this. So I'm glad everyone enjoyed it.
This is also really amazing watching everyone's presentation and watching the retrospective. There's coming not from this world of computer graphics and real-time events. It's already been a great journey working with A. Thomas and ShowCap, and this is amazing what we can do nowadays. So very exciting for the future.
Cool. Well, congrats, guys. It was really great to see, and we can't wait to see what else you guys churn out in the future.
Thanks.
All right.
Thomas, congrats, man.
All righty. So it looks like, all right. So I'm being told that from the control room that the winner of the Best in Show Award is I Am AI, AI-driven digital avatars made easy. So we are going to call up Brian Catanzaro, Vice President of Applied Deep Learning, and Arjun Malia and Kevin Shi. Hey guys, congratulations.
Thank you. Thank you.
Ready to even?
Yeah. Smile, man. Good job. Good
Thank
job.
you.
Thank you. Wow. What should we say?
Come on, say a few words.
Yeah. So
it's been
Go ahead.
It's been an amazing experience working with a lot of people, combining a lot of technologies that we developed at NVIDIA. So it's been really great putting all of those different pieces together and making it work end to end, real time. Yeah.
I'm
Happy to have a great team.
Yeah, very glad to have the chance to show off our technology in this SIGGRAPH real-time live demo. It means a lot for people who work on real-time rendering, either through traditional graphics or deep learning. And we are hoping that our technology can help you build the avatar more quickly, higher quality, and make more interesting applications. Thank you.
Cool. Well, thanks a lot, and congratulations again. I was with you through all the rehearsals, and it came off really well. You guys did a really great job.
Thank you.
Thank you, Chris. Yeah.
All righty. Well, I wanted to thank the Freeman video streaming and production team. They did an amazing job. This is already a very difficult show to pull off, and it's not any easier where all of the participants, including the person emceeing the event, are all in different places all around the world. So thank you so much to you guys, and thanks as well to Epic Games for letting us use the building here. And that's it for this year. Can't wait to see you all next year. And thanks for tuning in and watching. And thanks for everyone for participating. It was really great. It was awesome stuff.